Alright, hello and welcome to geometry. We are today looking at transformations. To transform something from an original shape to a new shape. The original shape is called the pre-image, and the new shape is called the image. So we've got a pre-image and an image, and we're always moving or doing some kind of action to it. There are 4 different transformations that you can do to a shape. The first is a translation. A translation is just a movement or a shift. I like the word shift. So a movement or a shift. So I can move or shift this pre-image triangle ABC. So let's say we want to move triangle ABC, and we want to move it left 4 and down 1. So left 4, down 1. So I'm going to move the entire shape left 4 and down 1. And I think the challenge that some students have is that they want to just move the whole shape, and that's not a good idea. So let's go ahead and move one point at a time. So we're going to move point A, which is the pre-image, to its new image. So we're going to go left 4, and let's say that A is at right 3, up 3. I'm not putting any marks in, but you can kind of visualize. A is moving left 4, so 1, 2, 3, 4, and then down 1. So there's A prime. Let's move the left 4 and down 1. So this is the pre-image, and this is the image. It's a new shape. B, let's say we want to move it left 4 and down 1 as well. We want to do that to all the points. So we're going to go left 4, down 1, and there's B prime. And then we need to move C left 4 and down 1, and there's C prime. And if we did it correctly, we should get a new shape. And these shapes are congruent because they are the same size and the same shape. Same size and same shape, so they are congruent shapes. The image, which is A prime, B prime, C prime, and the pre-image, which is ABC. And that's all a translation is moving left and right, up and down. You're moving the whole shape around. So that's a translation. Okay. All right, so the next one we're going to look at is a reflection. So a reflection is to mirror across something. So we're going to mirror across the y-axis. So we could say reflect across the y-axis. There's many different ways to reflect. This is just one example of a reflection. So to reflect across the y-axis, what we would do is we would look at this line as our mirror. Okay? And since y is our mirror, we want to flip across. So if it's 3 units to get to the mirror, then it must be 3 units away from the mirror as well. So then we're just going straight across, and there is A prime. So we've reflected A across the y-axis. Now we need to reflect B across the y-axis. And if it's 5 units here, then that means it's 8 units to get to y. So from B to the y-axis is 8 units. So we also need to go 8 units over. And so here's B prime. So far so good. And then the last is C. If we said C is 7 units, or maybe 6, probably closer to 6. 6 units, then we need to go 6 more units past. And so we have C prime here. And it's reflected. So we just reflect it across the y-axis. So that's a reflection. And so we're going to look at each of these in depth. But this is just the reflection. Alright, next we are going to look at rotations. Rotations are definitely more challenging than translations or reflections. Rotations get confused quite a bit. So I like to think of chess. So in chess you have the horsey. Okay? And this piece, and I'm sorry my picture is awful. It's pretty funny though. So the horse, it can move up to, so if this is where it starts, it can move up to and right one. Up to right one. Or it can move right 2 and left 1. Or it can move down 2 and right 1. Or it could move right 2 and down 1. And so on. So it always does 2 and 1. 2 and 1. 2 and 1. And 2 and 1. So if you notice, this piece has 1, 2, 3, 4, 5, 6, 7, 8 different places it can move. And oftentimes it's going to be the same for this type of thing that we're doing with rotations. So rotations, we often have 8 different choices. We've got to make those choices. So a rotation about the origin. And let's do 90 degrees counterclockwise. So I've got a lot of symbols that I've written down, some that you may have not seen before. One is the word origin. Origin just means 0, 0. So that's our center, and we're rotating around that. Like a bicycle wheel, we're looking at the spokes on the wheel, and the center of the wheel is at 0, 0, always, if we're talking about the origin. So we're rotating about the origin, and we're going to do 90 degrees counterclockwise. So this is our center, and we went right 3, up 3 to get to A. A is 3, 3. So it's kind of unique in that it doesn't have quite so many positions that it can go. So right 3, up 3 is the same as up 3, right 3. So the only 4 choices that A prime has for a rotation of 90 degrees are these 4 points where it started, and then these 3 points here. That's it. Those are the choices. So we're going about the origin 90 degrees counterclockwise. So clockwise, a clock moves in this fashion, right? So counterclockwise means it's going this way. And 90 degrees is 1/4 of a circle. A circle is 360 degrees, so 90 degrees is only 1/4 of the full circle. So we're moving 1/4 of the way, so here is A prime. So hopefully that makes sense. Okay. So it wouldn't be these two. So this was the choice. It's the correct choice. Okay. All right, B, we said 4, 5, 6, 7, 8. So this is right 8, up 3. So all points are x comma y. So in the x direction we went right 8, and the y direction we're up 3. So that's where point B is 8, 3. So there's a lot more choices here, because you can go right 8 and up 3, or you could go up 8 and right 3, or you could go down and right 3. Or you could go right 8 and down 3. You can go left 8 and down 3. Or you can go down 8 and left 3. Or you can go up 8 and left 3. Or left 8 and up 3. So notice there are 8 positions, just like our horse here can in chess have 8 different moves depending on where it's at on the chessboard. Likewise, B has 8 different choices. 1, 2, 3, 4, 5, 6, 7, 8. 8 being the one that it started at. Okay? So, again, we're going counterclockwise 90 degrees. That's 1/4. 1/4 of 8. 1/4 of 8 is 2. We need to make 2 movements. 2 movements counterclockwise. So we're going this way. 2 movements starting at B. 1, 2. There is B prime. So we have A prime, B prime, and all the other options were not going to work. Okay? And the last is C. So C, we've got to move counterclockwise 90 degrees as well. So if we were to count 1, 2, 3, 4, 5, 6, it looks like it's 6. And then 1, 2, 3, 4, 5, 6, 7. We'll say 7. 6 comma 7. So again, we've got right 6, up 7. That's where it started. Or right 7, up 6. So that's its other choice. Or left 7, up 6. Or left 6, up 7. Or left 7, down 6. Or left 6, down 7. Or right 7, down 6. Or right 6, down 7. So 2, 4, 6, 8 choices. And so in these 8 choices, we're going counterclockwise. So we're starting here. 1, 2. So this is C prime. We'll get rid of these because they weren't any good. And here's our C prime, A prime, B prime, C prime. And so we've rotated 90 degrees counterclockwise. If we had done 180, it would have looked something like this. And if we had done 270 degrees, it would have looked something like this. Where this is C and this is C. You can see how it rotates. It's always facing a different direction, right? So this shape here is congruent to triangle ABC. So the image is congruent to the pre-image. And that's interesting. So again, in translations, reflections, and rotations, they are all congruent shapes. They're the same size and the same shape. Different orientation, though, if you think about it. This triangle is oriented with C pointing up, and here the orientation C is pointing to the left. Now, circular orientation, it's the same, but let's not get into that. C in our pre-image is the pointing up of the triangle, and here it's pointing to the left, if you think of it that way. C is pointing to the left. So it's got a different orientation, whereas with a translation, we didn't get a different orientation. Reflections we do. We did get a slightly different orientation. If you think about it, B was facing to the right, and when we reflected across the y-axis, B was pointing to the left. So that was a slightly different orientation, but still congruent. So in all three of these, we always get a congruent shape out of these transformations. Okay? All right, let's look at the last one. All right, so the last one we're going to look at real quick is the dilation. So a dilation is a shrink or a stretch. So we're either getting smaller or bigger, generally. So there's some weirdness going on, but we're not going to look at the weirdness right now. I just want us to understand what a dilation is. So I could say I'm going to dilate about a specific point. So I'm going to do about the origin again. And that's pretty nice. And so generally speaking, we usually do it about the origin because it's a little simpler. Same with the rotations. You don't have to do it about the origin. You can do it about any point, 0.3, 2. So we could dilate or rotate about any point on here, and I will show you how to do that. But we don't have to. There's an easy method that I will show you to identify a new point as your point of rotation or dilation, and then turn it into the origin, and then you can do what we've already seen. So, but we'll get there. So we're going to go about the origin, and let's do a factor. So by a factor of by a factor of 2. So a factor of 2. Factors meaning multiply. So a factor of 2 would be multiplied by 2. If it was a factor of 1/2, we would be dividing by 2 or multiplying by 0.5, which would be shrinking it. But a factor of 2, we're making it bigger. And then you can also do negatives. So negatives would actually bring it over here into the third quadrant. But since we're doing a factor of 2, we're going to be further out in the first quadrant and be much bigger. So we can do this by points as well. So you could have 3, 3 is point A, and so we're going to take each of our numbers and multiply them by 2. So 3 times 2 is 6, 3 times 2 is 6. So our A prime, which will be our image, will become 6, 6. So we're going to go right 6, up 6, and here is A prime, 6, 6. We just multiply by 2. B was 8, 3. So 8 times 2 is 16, and 3 times 2 is 6. 16, 6. So 9, 10, 11, 12, 13, 14, 15, 16, 6. Same height as A, B prime. And then C was, I think we already decided that it was 1, 2, 3, 4, 5, 6, 7. That's right. I remember that now. 6, 7. So 6 times 2 is 12, and then 7 times 2 is 14. So 12, 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and up 14. So 9, 10, 11, 12, 13, 14. There's 12, and then 14 is way up here. C prime. So A prime, B prime, C prime. So here is our pre-image, ABC, and our image is A prime, B prime, C prime. And since we did a factor of 2, we doubled its size. Technically, we doubled the distance from A to B, we doubled the distance from A to C, and we doubled the distance from B to C. So it's not just doubled in size, but it's doubled in its lengths. So that's pretty interesting. So that's a dilation. One of the things that you can do to tell whether or not your dilation worked is you can draw a line from where you're going about. So since we went about the origin, we're going through 0, 0, and we're going through A and A prime. And notice they're in the same line. So that's good. And then we can go through B. And I might have put B a little low, it looks like. I should have probably put it up a little bit higher. And then C. And it should be in line. It should make a straight line. So if you've got graph paper, you can do this very accurately and make sure they should be always in line. Notice that these dotted lines will cross each other. They cross through 0, 0 because C, if we had done a negative, if we had done it times -2 instead, we would have ended up with C down here, and we would have ended up with B around here, and then A, of course, would have been around here, and we would have gotten the big triangle that we got over here. We would have gotten that same big triangle, but it would be flipped. So instead of C pointing up, C is now pointing down. So that's kind of interesting, something to keep in mind. But really, we're not going to worry about that right now, because today we're just going to focus on translations. So I'll let you take a break, and then we'll come back and look at just translations. This is kind of an overview of all the different types of transformations: translation, reflection, rotation, and dilation. Those are the 4 types, and we're going to focus our attention now on translations.